Hello, hello, hello. I hope you're doing fine. Let me just prepare a little bit. Oh, the music is a bit loud actually. Okay, is it good? I mean, I suppose it is. Okay. So let's prepare. We have the chat. We have the two chats. This doesn't exist. This chat doesn't exist. Good. Oh. Wait 2 seconds. Okay. Okay, hello people. Hello, hello, it's me, and it's 5 AM. I just can't sleep. I just can't sleep. So I mean, let's just play the game. And actually, when I started the project this morning, well, like 10 minutes ago, I removed the dash GPU comment argument. And as you can see, it's not lagging anymore with time. Like before it was kind of, there was like some kind of leak. Hello, Calculus. Hello, hello. And yeah, basically, what happened? Basically, the good thing is that we have this entity. We have this thing that is rendered by our second, not pass, but a second what? Second pipeline, I guess? Second renderer, I guess? And it's good. But the problem is that I can't set the position right now. Like every object is going to be here, in the center of the world. OMG, hey, repeat! So yeah, every object is gonna be here. And that's not what we want. What are we gonna do? I guess we want the storage buffer with like everything. Teach me, master. Oh, master. Master. Sure. My apprentice. Let's get started, shall we? So this doesn't move? That sucks. So what we want now is is another buffer, technically. I have to think a little bit. Because technically I should have a compute shader before that, but right. I mean, I guess... Yeah, I guess that's fine. Is it? Yeah, so we're gonna have a storage buffer, I guess. And we're gonna try to access that from the GPU, obviously. So let's go to opaque entity renderer, and we should have like a create shader, create vertex buffer, create index. Yeah, something like here. Boom. Creates entity buffer. Yeah, I guess right now it's called entity, well, entities, right? And that's not really what I want. I want to call it comments buffer, but I think it's like something in Godot already, right? Wait. Comments buffer. Yeah, well, it exists. So I'm gonna call it like indirect. Well, or like comments, maybe. Like indirect comments. Can I just rename? maybe... I'm not sure about that. Indirect comments. I mean, yeah, if you have any question... Oh, man. So many people. I'm surprised. It's all of a sudden at like 5 a.m. But yeah, if you have any question on what I'm doing, please go ahead. The goal is to create a new buffer with the transforms, so we can access the transforms on the GPU, so we can move the objects around. That's it. That's all. Just gonna remove this. And entity... I'm gonna do that. Yeah, okay. The right... It's modifying the right thing. Good. Okay, should be fine. Update and buffer and... Well... Yeah, let's remove that. Let's rename that. Buffer entity, what is that? Indirect commands, let's say. And yeah, we're gonna have to change a lot of things. But that's fine. So we still have this. We still have this. We have... What do we have? Create objects buffer, maybe. So maybe here we are gonna have... I mean, I guess it's... I mean, this one I guess is entity. I mean, object is fine. Object is fine. So we are not gonna have the indices this time. We're gonna have something a bit different. Index array create. So instead this is storage. Well, it's not even an object. It's just storage buffer create. And I guess we only need this. And potentially the storage buffer usage. Storage buffer usage dispatch. No, I think that's all I need. And I need to... I mean, I need a few things. I need a few things. I guess I need my data. Oh, Superstan, hello, Arcsaber. Hello, hello. Entity. More like command. Let me just think about it a little bit. Entity. Yeah, indirect command. What's on the menu for today? Basically, right now, we managed to, like last stream actually, we managed to get this. We have a cube right there. And it's supposed to be our entity, right? And this is pretty good because, you know, it doesn't seem like much, but this is actually the first time I'm implementing indirect rendering. And what does that mean? That means that it's very fast. It's very, very fast. Performance-wise. It's like, well, I almost want to say that it's like free. It's kind of like not free, but if you compare it to like, yeah, it's very good. Like for the CPU. What does indirect means? It means that, oh, pickup pipeline. Let me just show you an example. So in OpenGL and like, you know, simple pipelines, you could say. Usually when you render things, wait, that's not my render pipeline. Wait, where is it? Pick up, okay. Usually when you render things, you have this, wait, filter, you have this loop right there. Well, actually this one. You have this loop, okay? You have a loop that loops over all of your objects and that tries to draw them. And every object is going to bind their own vertex array, their own index array, their own uniform set, and then, you know, push some stuff maybe, and then they're going to draw. Right? That's like direct rendering, because like for each object you directly, each frame tells the GPU to poof, render that please, okay? Indirect means that instead of doing that, you call this from a buffer. Because basically the goal is to reduce state changes, is to reduce the amount of bindings you do, okay? And yeah, because like basically every time you bind something, that means you send something from the CPU to the GPU, okay? And you know, synchronization between the CPU and GPU is like slow, and you want to prevent that. Ooh, that's not good, right? So what we do instead is, instead of all of those bindings and stuff, we have this, where we only have, in the draw, we only have one, we only have one single, you could say kind of like object. We have like a vertex array, an index array, and a push constant, but that's all we do, right? We don't do that for like all objects, okay? And we draw indirect, right? That's the name of the command. And instead of, you know, like sending each object, basically, you're going to send a buffer that contains those kind of commands, like this, well, this kind of data, that describes how each object is supposed to be rendered. Why wouldn't you indirectly render everything then? I mean, usually, well, like indirect rendering would be the goal, but it's like a bit of a pain in the ass. And check your, wait. It's an artifact. Mainstream output? What is that? Oh no. Oh, thanks a lot. There's a ghost. There's a ghost just... What the fuck? Why is there a ghost? Can I refresh? Oh, okay. Okay, it seems to be good. Thanks a lot. I refreshed and it was still there, so I had to check on my phone. Thanks. I had like a ghost for whatever reason. Actually, it's like the web thing that shows, you know, when people subscribe and stuff. But I mean, thanks, thanks. And yeah, basically you have those commands, right, that describe how you're supposed to draw each object. And why don't you do that everywhere? Basically because it's a way to... Well, when you do indirect rendering, you basically put a buffer on the GPU, and you know, the goal is to update it as less as possible, right? But the thing is, for example, for my chunks, when I move around, I'm going to update my chunks, right? Each chunk is unique. I can't reuse the same chunks, so I can't like do instancing, for example. Well, not much. And you know, it's like a bit of a pain because I can't, well, right now to do my indirect rendering, I basically put everything inside the same vertex shader, right? I have one big vertices buffer, I have one big indices buffer, and that's it. And I put everything inside. So it works well when the meshes are not changing and when I know them ahead of time. But when I have chunks, like, you know, chunks, to optimize them, I like curl faces that are, you know, facing like another block, right? So I have basically custom meshes for each chunk. And that means every time I modify a chunk, this chunk is going to be changed, the mesh is going to be changed. And you know, if it's like a single big vertex buffer, what does that mean? How can I increase the size of a vertex buffer, right? Does that mean I have to make my own, you know, pool? Like, do I have to remove the object and try to put the new one inside? What if it's not fitting, right? There's like a bunch of problems with that. That's why with chunks it's like easier to create a new vertex buffer. Easier, but you know, technically it should be better. But it should be better to draw indirectly, as you said, probably. I mean, it depends, right? But yeah, it's a bit of a pain. So for now, I'm keeping the, you know, the normal straightforward method, I guess. And that's why for entities, though, I'm supposed to know their shape ahead of time, right? Like, for example, when I drop an item on the ground, it's supposed to be, you know, kind of always the same mesh, right? Whether it's like a cube or a quad. Or maybe like enemies too, or like the player, right? It's not going to change a lot, at least. So that's fine. And this is going to be inject command. I'm just updating the naming a little because it sucks. Yeah, that's fine. I can do that. Wait. Opaque entity render. Boom. Boom. Okay, Naruhodo, but not really. I have no sense how the actual computations look like, because it's too deep for me. I don't even want to code if possible. Oh, I see. I mean, I can explain it pretty easy. Like, wow. Well, I mean, maybe, well. Basically, you have the GPU. CPU, actually. You have the GPU, right? And the thing is, you have data on the CPU that you want to move to the GPU, right? So, I mean, for vertex buffers and that kind of stuff, you put it ahead of time there, right? It's like big arrays. But then you're still going to, like every frame with direct rendering, you still push some commands, right? You tell the GPU, hey, please render this and this. Well, and like, and this. And another one that says, hey, render this, right? And the command buffer is basically, instead of doing that each frame, you have this buffer that you push one time at the beginning, and that you can update from time to time. But then this buffer just tells the GPU, hey, please render all of this, right, instead. So you don't have to do that. Yeah, that's it. That's all. That's what it does. But basically, if I have to explain just the last thing I was explaining, like this buffer tells how you should like draw this, right? But with meshes, with chunks, I mean, you create new vertex buffers, like this. And, you know, when you push the command, then you don't know this, really. So, you know, you can't really use it. Well, yeah, it's a bit complicated anyways. Yeah, I get it on a theoretical level, but I have no sense how much actual computation is being saved. Yeah, I have no clue. I have no clue, but very smart people said that it was faster. So I'm doing that. Okay. That's it. Wow. I mean, technically it's good. Well, when you check, you know what? I'm gonna show you something. I mean, I'm gonna show it to myself too. So I have Tracy open, and I guess that's gonna be it. I'm gonna stop recording. Boom. So when I look at this, I have the render thread somewhere, right there. We have record command list. Okay, I don't know what all of this is about, but basically everything here, like those 253, right? All of those little calls, are basically me binding the pipeline and telling the GPU to do something, right? And you know, it's like very fast, right? It's like 1 or 2 microseconds. But the thing is, when you have like 200 chunks, it's starting to accumulate. And 2 microseconds turn into, you know, 2 milliseconds, for example. And it's taking time. And the goal is that with indirect rendering, you can basically remove this, right? Like you have big instances, I guess. Don't really look at those, but like exceptions. But yeah, basically you have all of those. Micro. But you have micro. Well, nano, micro. I guess it's more like 200 microseconds instead. But yeah, the goal is to remove all of those little calls. It should be working pretty well. Like if I look at record command lists. Okay, this one is like the opaque entity renderer. There's like a few... It's taking like 20 microseconds actually. So it's like a bit more than the draw opaque. But if it's like only one call instead of all of this, right? It's like better, I guess. I didn't think it would be like 20 microseconds really, but... Can I go somewhere else? 20 microseconds. Yeah, this is a bit surprising actually. What am I doing in there? If I go here, draw. Oh, I guess I have this. That might be taking some time. Yeah, probably. Because then we have... Like for the main pass... Like the main pass is like really big, right? This is like the pickup render pipeline. It's like 3 milliseconds. Right? So let's say this is like 1/3, or like a 1/4, let's say. Then we are saving almost 1 millisecond of render time. Yeah, I have no clue what this is. What the big hole is. I'm also a big fan of the method of trusting very smart people. Yeah. You know, just you make it sound like you're smart, but you're actually just listening to smart people. I mean, I guess maybe that's the way to be smart. Maybe that's what being smart is. Just listening to people. Or knowing how to, I guess. Because sometimes I guess you don't want to. Listening to the right people. You can't invent everything yourself. Not enough time. Yeah. Yeah. I guess. Yeah, I guess so. And I mean, it's not... I mean, if you had to invent indirect rendering, then, you know, you'd have to, like, invent the thing on the GPU, right? You'd have to code on the GPU. Like, you'd have to reinvent Vulkan. So, that would be pretty bad. But, well. So, we have... let me actually just search for entity. Because I want to entity index. Yeah. This is indirect command index. Oh, wait, I just want to focus on the buffer. Wait, did I push? Wait. Because this is a big step. I haven't pushed. Oh no. Collision loader. Yeah, there's like a bunch of things I haven't pushed, it feels like. Right, let's do... Like... Okay, let's just add this commit, I suppose. 41.3. And this is collision loader. Destructor now waiting for thread to finish. And maybe a crash fix, basically. Okay, now we have all of this. I mean... Yeah, that's basically things I did. Yeah, I basically removed everything. Or commented everything. Okay. Yeah, that's like some cleanup. Okay, let's push that. I mean, maybe let's just finish... create... Wait, let me... Create object buffer. For now, let's remove this. Well, yeah, I'm gonna go back to it at some point. I just wanna clean things first. Entity index. Okay. Inject command index. Match to entity buffer. Not really though. Wait. Match to entity buffer index. I mean, I guess... You know what? This is gonna be fine. Is it? No, it's not. I have no idea. Maybe... Yeah, I'm just gonna rename this to... Indirect command buffer index. Okay. And now it should be fine. So I'm just gonna add this. Maybe I have something on the... Wait, what is that? Right. Maybe I have something on the game side too, to push. But for now, let's just add all of this. And it should be fine with the register types. And it should be good. So now we have... Oh no. I just realized. Git reset. Oh no. Let's reset. Let's do reset soft head. Head 1. And instead we're gonna push again, but with the right number. Right. 41.4 instead. Right, because we already had that. Now we push first. Now we're gonna push this and this. Yeah. And this is gonna be 42. 42. Opaque cube, opaque entity render. I mean, technically I don't need this though, right? I'm not using this. So, let me just remove this and this. Opaque cube voxel, opaque cube voxel. As long as I'm not including the file anywhere else, yeah, that's fine. Okay, good. And this is opaque entity renderer added using indirect instancing. Well, indirect rendering, I guess. But object buffer hacking, I guess. Okay, we have this. We are gonna maybe modify things here too. Probably completely. Game manager. I mean, okay. Main. Torus space. And that should be it. So 41.4. Oh no. 41.4. I mean, I guess it's fine. You know what? I guess it's fine. It's fine. It's fine. So, 42. Entity. Well, opaque entity renderer added. Boom. Here we go. So now it's time. Now it's time. It's time, boys. We are gonna create object buffer. So we go like here. We're gonna have this. We're gonna have this. I'm just gonna... Well, I can copy this again. Can remove that. Storage buffer create. I can remove this line. We have the data and stuff and the size. So yeah, this is the size in bytes though. Right? So we want to reserve a certain amount of space. Really? Let me think about it. NB max objects, maybe something like that, right? NB max objects equal... I mean, it's instance rendering, right? So maybe something like this. So byte size is going to be something. Data. Do I really want data? I don't want any data. I don't care. This is null. Well, I guess it's just empty. Byte size is gonna be this. NBMax objects times a class that's gonna be object data, I guess. So we have the transform, or like transform 3D, I think. Basis origin. Yeah, that should be good. Right? Like, what am I doing actually for my chunks? Q chunk visual. Push constant. Project, well, no, not projection. Model. Actually, we do have wait, what? We have projection for the model. I guess so. Wait, how does that even work? Model equal get global transform. Yeah, this is a transform 3D. And this is a projection? I mean, I guess it's technically the same. Does that take transform 3D? Yeah. Yeah, so it's technically okay, it's technically good. And just updates. Okay, I guess it's good. I guess we want this instead. We have the transform like the model I guess the model. And I guess that's it for now. So that's gonna be very simple for now. Pretty simple. We have the size up. Object data. By size, okay, so this is good. We just want to assign it to the right object buffer. Well, to the right buffer. That's gonna be the object buffer. Boom. And we are going to create this when we create the other the other buffers. So something like here. Right? We do that one time. We reserve. And I guess that's it. And then we want probably an array that tells us what spot is free or not. Or I guess it's like a free list. Does that exist? Fixed size free list. Ho. Wait, that's in Jolt. Oh, I don't want Jolt. Free list. What about free list? That sucks. Technically, I could use paged allocator. That works the same. But it would be kind of like a cheat, I feel like. And yeah, let's not. Well, basically we can have our free list ourselves. Do I want to implement that now though? I mean, I need an array in the first place. I need a vector. That's gonna be object data. Objects data. Okay. Inside I'm gonna have my things, right? Is it going to be the same size? I mean, I guess I might want to allocate it ahead of time. So... I mean, I could implement this if I want to. Well, I kind of want to. Because just using like one transform is like simple enough. The problem is really when you have multiple objects and you want to spawn them and unspawn them, like remove them dynamically. That's the actual challenge. But we can start simple. Yeah, we can start simple. I have to check this too. Indirect command, because we have the buffer and first instance. Yeah, first instance is going to be a bit different. Well, we're gonna have to change this dynamically, potentially. So you know what? Let's remove this. I mean, we shouldn't like create commands here, anyways, in the first place. We have to generate them. That would be the goal. Yeah, I'm just gonna comment this for now. And what do we want? And how can we add entities dynamically and remove them dynamically? I guess we want to update the buffer. I mean, I guess that's it, right? It's just a mesh. Yeah, it should be add entity. Well, maybe not. Well, no! I have no clue. It depends what entities are being rendered, like what meshes are being rendered, actually. But I mean, do I want to optimize? What do I want to optimize? How do I want to optimize? Do I want to keep a command for each entity, even if it's like not rendering them? No, I don't want to. Probably not. Yeah, I guess I'm gonna have to recreate the buffer like every frame for like cutting to on the GPU. I'm gonna have to do that on the GPU anyways. Right. I mean, for now, I guess we can do that on the CPU. So I'm just gonna have to update this. I'm not supposed to push. I mean, it's like pretty good, but I'm not sure. Because I'm gonna have like a struct very similar to this, I feel like, anyways. Maybe like the same. But it's just the first instance that might change. Because there's instancing too. Well, basically I have indirect rendering and I also have instancing. So that's why it's a bit tricky. If it was just indirect rendering, that would be fine. But with instancing, that means I need my objects next to each other. Do I? Actually... I'm not sure about that. I mean... So let's say I'm instancing. That means my instances are going to have IDs next to each other, right? Do I want a second buffer? I don't really want to have one. I mean, if it's just objects, I mean, I don't know what data I'm gonna have inside. How much data? Let's not overthink things. Let's just fix things one by one. So first, well, let's first have something that works, right? So we have objects data. And it's gonna be something like, where's just a mesh, add entity, update indirect command. I'm not sure about that. So let's just push the mesh. Well, not the mesh, but object data, I guess. And I mean, I need the... It's not just the mesh, I need a transform. So... let's just add this. Add entity. Okay. We have this. But now the add entity is gonna have a problem, right? Because we don't have the transform. Do I want a U object for that? Something like this? Like a resource, actually. For now, I can just add entity mesh. Wait a second. That's not really what I want, though, right? Well, never mind. Okay, no, that's fine. So we have the mesh. Let's say we have the transform 3D. It should be like a projection, is it? Wait. I don't know if it's transform 3D. Wait, I have to check variant. If it's inside variant, transform 3D, okay. What about projection? Oh, it is inside. It is inside. So maybe I want projection. Technically it's a transform, but object data. And it's from the non-resource thing. So we have this. What's that? Is inaccessible. Oh no. Let's make it accessible then. Okay. And what's the deal? Too few arguments. What are you talking about? Data dot... Oh no. Okay, yeah, it's a struct. Data.model equals transform. I don't... Oh. Right. Is this, right? Wow. Too few arguments. What do you mean? I only have two arguments. I don't get it. I mean, that should be fine. So we push back. I want objects of this, well, with the same mesh to be contiguous though. So that would be kind of like a pain. Because that means I have to move everything, I have to copy everything. And push back everything to the GPU. Is it worth it? Because basically the problem is that if I do that, it's going to be more optimized every frame. But when I'm adding a new entity, I'm afraid that there's going to be a freeze. So do I want FPS stability, or do I want to reduce the overall FPS down? Kind of. That's the question, because I don't know how it's actually going to impact performance. I mean, it's probably not going to do anything, right? Well, for now, like with only a few entities. But That's the kind of thing I have to think about for the project to scale. Let me actually ask ChatGPT. Or like, yeah. So inject buffer with a single, well, single inject buffer with a single vertex buffer and index buffer for a lot of objects. How can I have that with instancing? And what? And retrieve each object's transform in the shader. What do you mean? One draw per object, most common. I don't want to do that. That's my problem. Oh, no, okay, draw, not buffer. Okay, yeah, okay, my bad. One draw per object. Yeah, first instance, 1, 1, 1, so that works well. But many instances of the same mesh, that's what I want. I want instancing. That's like another optimization, right? So inject command becomes all of this, and we have all of this, right? From 0 to 500. But if I'm using the first instance, then, you know, that means it has to be contiguous. This is the standard approach. Yeah, I mean, many instances. What if I want to fuse both? Yeah, mixed meshes, that's what I want. It becomes this. Yeah. The shader never needs to know. Yeah. But if every object has a different mesh. No, that's not what I want. Common render layout. Yeah, I mean, this is fine. During coding. Okay. Wait, you emit one inject draw command and pack all visible instances for that mesh contiguously in the instance buffer. The vertex shader retrieves the correct per instance data. Wait, that's like another problem. It's like the culling, right? I forgot about that. Group visible instances by mesh. Yeah. For each mesh, you emit one inject draw command and pack all visible instances for that mesh. So, yeah, question is, when culling, for example, how do you handle that? So, if you want to cull objects, well, let's do mixed meshes. If you want to cull objects, well, some instances, how would you handle that? Because you're going to have, like, the instance is going to be wrong. The instance ID might not point towards the right object anymore. Never rely on a persistent object ID being equal to the instance buffer index. Instance buffer is usually a compacted visible instance. Yeah, well. So we have all of this, we have the objects with mesh ID, material ID. Buffer is stable. Okay. After culling. So we have all of this. Indirect commands reference this buffer, not the original object buffer. Oh, right, because it creates a new... Yeah, it creates a new buffer. Never mind. Yeah, that makes sense. Yeah, for the culling, it makes sense. Yeah, it creates a new instance buffer. That makes sense. Wait, what if I need the... No, never mind, because you have the new... Yeah, you have the new one, but... Wait. Yeah, but you still need the original ID because you need to get the data for the transform and stuff. I did. Wait, what? Huh? 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 That means I have to update visible instances though, right? Compute shadow does something. So I have to update the visible instances. Visible buffer is rebuilt every frame. I'm not sure about that. Alternative. Sparse instance buffers. Yeah, that's what I was thinking about too, but yeah. Perfect's a game with thousands. Nah. What if I add a new command? Well, I guess... Yeah, it's just not going to be instanced. But... I kind of have both. It depends. Probably have out of this. First instance field is basically there specifically to let you do this kind of compaction. Isn't it really bad? Isn't it bad performance-wise to rebuild this every frame? Just a little. I mean, it's just a matrix, right? But is it? Well, I mean, I guess on the GPU, when you have like millions of triangles, then I guess it's cheap. Okay, I guess it can be cheap in that case. Well, if you have out of this, that's trivial. It's not writing the buffer. Transforming vertices, rasterization. Yeah, I mean, that's fine. The compaction with cutting. Don't copy everything. You create a lightweight draw instance with the index. Yeah, that makes sense. So it's like a buffer that redirects the data. It just redirects. So you get the idea and then you get the transform. Another common approach, indirect command generation. You don't even rebuild the instance buffer. What? Visibility mask. Huh? I mean... I guess... Oh, I guess so. For a voxel game specifically... I mean, it doesn't matter. Yeah. Ring buffers. Oh, that's good. I like that. So I guess one last thing... Wait, what did I want to know? One last thing I wanted to know is... Yeah. Well, I guess it's actually the first choice it was giving me. Well, the first option. Option is one draw per object. Right? And that basically means one draw per object is basically one command. Right? Does that mean one command per object instead? And I mean, I might go to this. I might go do this because it's like the easiest thing to do. It's like the easiest thing to do, really. Yeah. Simplest GPU-driven architecture. Yep. You can keep one comment per object. One draw per object. Batch by mesh. Yeah. GPU compaction. So what I really want, I think I need another buffer. Probably. Yeah, I might just have another buffer. Whoa, that's a lot of buffers. Object buffer. Well, okay. And then we have the object buffer, like the object data, right? And we have the redirect. Object redirection buffer. Or like instance to objects buffer, I guess. Instance to object buffer. Yeah, I think that's what I want, really. In the long term. There's going to be a lot of array, like a lot of buffer sampling, but that should be for the best, right? I hope. I'm not sure. I'm not sure because that means one more array access too. Well, buffer access. But I mean, I'm gonna have like different data. I'm gonna have my transform. I'm gonna have the texture. I'm gonna have a bunch of things. So the normals. No, not the normals actually. Actually, there's not a lot of things. I might want to keep things simple. Let's keep things simple for now. Let's just not have this. Okay? So we're gonna have this, we're gonna have the object buffer with the maximum amount of objects. I don't know what this is. And well, technically we're gonna have a compute shader after that, but not now. Object buffer, so we have this. I guess we want to update it. Right now we're just gonna update it every frame, okay? But that's fine. That's fine. Actually, there's like a push. Object data pushback. I guess pushback is fine. Is it? Like, I do want to reserve, I feel like. At least. Oh, not here. Like there. With NVMax objects. And I guess that's gonna be it. And I'm just gonna add maybe in the draw actually. So we have the draw, and before rendering, I'm just gonna ensure that condition. I'm just gonna ensure that this is more than objects data. That size, right? I want to make sure of that. Well, and that means it's gonna fail if it's higher than that or equal. Okay, that's good. And now every frame. That's kind of bad, but the goal is to put it on the GPU afterwards. For now, it's just, you know, testing if like the thing works overall. So we have a lot of... do you have to update the buffer before the draw command, actually? I suppose you do. Probably do. Okay. Let's do this. So RD update, like storage buffer update? Well, there isn't. Update buffer, I guess. Buffer update. Or ID. This one. The offset 0 size. Memory size. So this is gonna be size of this times this, I suppose. Okay. Yeah, that's gonna be very bad right now. So then we have the data, objects data.ptr. Okay. Skip check. I mean, this should be fine. Let me just check this, just in case. Queued into the render graph. Render graph will reorder this operation so that it happens together with other buffer updates in bulk and before rendering operations or compute dispatches that need it. Yeah, it seems good to me. So that's what I was thinking it was doing. So we update the big buffer every frame. I mean, maybe only if it changed. But okay. So we have this. Do I want to update the comments too? I might want to update the comments. Because right now I only have like one object too. So update that. Update object buffer. And then we are gonna have update inject comment buffer. So that should be on the GPU. To do move to GPU and co. Okay. Okay. So inject commands. This is the other one. I guess that's going to be kind of the same. With wait, And it is, yeah, I mean, technically, I guess so. So this one we update to with this. And that means technically every frame we can call this, right? We can update it. Well, we can, yeah, we can just run that every frame. That doesn't seem very performant right now, but it's like a temporary thing, right? Right? Buffer update. I mean, this one should be changed only when I'm adding a new entity. Actually, let me think. Because if I have the mesh index, I don't even have to update everything. I can just push the new entity. Then it's going to... Each entity is going to have like a mesh or something, a mesh index. And I can optimize things that way. Like hash mapping. I'm not sure about that. I mean, technically I can have something like that. Wait, is instancing really worth it? Is instancing really fast? Like, how fast is instancing? Incredibly fast. CPU to GPU. Only for that. Joe calls. That seems pretty good. Yeah, I mean, for my cubes, I probably do on that 10 times. Whoa. Whoa. When instancing can actually be slower. Yeah. Tiny meshes. Wow. Okay. GPU bound limits. Oh no. Oh no. Oh, okay. Maybe I don't want that then. On older or poorly optimized hardware. So it's like old though, right? Individual flexibility. So when already rendering indirectly, what's the performance gain of instancing? Yeah, it removes the CPU submission overhead. Instancing reduces GPU draw overhead. Wait, it reduces GPU draw overhead? I actually don't know how instancing is processed, is done. And duplicates state processing. Okay. One indirect command per buffer. Yeah. Yeah. Fetch. Wait. Okay, so what does it remove? Command processor overhead. That makes sense. State changes. I mean, you already have everything good with like indirect rendering for that, right? Textures. Yeah. Better GPU scheduling. No need to invent everything is already there. Everything, even my game, is already there. A large instance draw gives the GPU more work at once. And I guess there's also data, like cache, I guess. Cache locality. That's what I would have thought. One large workload instead of a lot of small ones. You need grouping. Not really though. I mean, I'm gonna do that for like specific blocks. Maybe that might move with like a different normal, but yeah. Usually unique because the block layout differs. I don't really care about that. Okay. What else? What else did I want? You know what? I think that's gonna be fine. Let's just not think too much about it. Yeah. Well. Well. Yeah, that's fine. Let's not think. Yeah, that's fine. We don't need to think. We can always do instancing kind of dynamically, right? Well, not well. What I mean is, instead of like trying to instance everything whenever it's possible, what I can do is that sometimes I can create like one new command for each new entity. That would be the default, but in some cases where I know I need a lot of entities, then I can just do like this. Like if everything is contiguous. Well, when I know it's contiguous, I can instance like that, I suppose. Yeah. Yeah. And I mean, I guess I can always sort it at 1.2 if needed. Anyways, it should be good. So update inject command buffer, we have the updates. Pointer, size. Okay. Should be good. What else? I mean, technically that should be fine. I guess I just want to recreate my buffer. Yeah, I want to recreate my buffer. And object data, this one is actually going to be... I do think I need the mesh. Do I? Do I need the mesh? I'm not sure about that. Wait. Yeah, redraw. Well. Well. Ah. I'm thinking about the compute shader right now. I'm waiting. Thank you. Thank you for waiting for me. Like the compute shader is going to be... Maybe I should like implement the compute shader, like make like a pseudo compute shader here. So I'm gonna have the base object data. Okay, I'm gonna have the wait. Maybe I need like a diagram or something. But basically, the plan is that we update everything like one time. Maybe we sort the objects from time to time for like instancing. And then we have the comment buffer too. Do we? Yeah. And then what we do is we create a new one where we have the final objects. So I mean, I need a compute shader for that. Yeah, that's like such a pain. You know what, let's just keep things like this, I guess, for now. Buffer update 32, so we update every frame. Potentially. I need to do something with my transform. Because right now it's like... Yeah, what am I doing with this? I mean, something good, I guess. Okay, so I'm pushing. Yeah, I mean, this one is kind of wrong. I suppose. Like, technically, it should more be a pushback inject command at this point. Instead of, like, updating this. Yeah, maybe I don't want to care about instancing for now. Yeah, let's not care about instancing. Instancing is too complicated for now. So if we don't care about that, it means we need a new inject command every time we have a new entity. So we can have this. Index buffer start. I mean, index counts. Can I just do... I mean, I do need the vertex buffer start though at some point. So I guess I need this anyways. Inject command index. More like mesh data or something like that. Mesh index. So we have the meshes. Well, not really. We have those things, indirect commands. Like descriptor, maybe? Mesh descriptor. Maybe? We're just gonna copy this with the index count, instance count. I can remove first index. I mean, it's basically gonna be. Oh no, it's not gonna be 0. Okay, that's fine. Vertex offset. Okay, that's fine. And first instance. I can remove this. And now we're gonna have oof, mesh descriptor. Mesh descriptors. So we're gonna have, instead of all of this, why do I have this? Well, let's just remove that. Well, yeah, basically right there, we're gonna have a pushback with mesh descriptor. Boom. And then we have, please, ready, please. Wait. Can I set something? Oh, it's a class, okay. Yeah, it's a struct. It should be a struct. First index is gonna be index buffer start. Index count is gonna be this. And vertex offset is vertex buffer start. Okay. So now it should be alright. We have the descriptors. Yeah, that's what I want. Probably. So this is it. Okay. So now we have index count. So basically we can just get the index. Right? It's a mesh descriptor index, really. So we have mesh descriptor. Well, something like this, but this is with an S. Boom. Okay. And now we do index count, first index, vertex offset. Good. One instance, I mean, this is fine. Well, this can be. Wait, is it? Yeah, I guess it's technically alright. Well. Yeah, I mean, okay, for now this is gonna be fine. So we push the data, we push the command. Then when we want to remove this, we can, you know, just retrieve this. I mean, I guess we want a specific object too, though. So maybe we want to return like a or ID or something like that. Oh, that's gonna be a pain. It's gonna be a pain. I mean, I do need to send the object's ID to the GPU, I think, because of the pickup render pipeline, potentially. Actually, that's not necessary, but yeah. Do I want that? Remove entity. Yeah, this is bullshit. That should be like a OID or something. Well. An ID. Yeah. It should be a OID, but I want a in32. So I'm gonna keep this for now. And this is gonna be pretty simple. Well, I guess I can get the mesh. Oh wait, if I have the ID, is that... I'm not sure. Do I want the mesh? No, I don't want it. Do I have the ID? There's the scriptor, So then I have all of this. I have... Well, what is that corresponding to? Oh, object data. Right. So I have this, and I push this. Good. So now I can basically just get the index of this, like find. 6, 7 AM. Okay. Find... Do I have like a version with like a predicate? Insert predicates. Template. Sort. Okay. There should be something in like algorithm or Godot, C++. Find, well, local array, find template. Well, predicate. Find if. Oh, right, find if. That doesn't exist though. It's only in vector and not local vector. That sucks. Find custom. Yeah. Oh, it does not feature that. I mean, I guess I can use the standard library. Manual indexed loop. I mean, it's supposed to be the same, performance-wise. Yeah, I'm just gonna std, I guess. Just gonna search. It does use std a little bit. Okay, let's do that. std, well, find if. So we need the begin. It's not optimized, that's fine. We have the end, and the predicate is gonna be... Boom. Object data. We have the objects. And we return whether this is equal to the ID. So we want to capture the ID. And this is it. And now we have the iterator, actually. So we have the iterator. The iterator? Well, I guess it does have an iterator. Can I erase it? With like an iterator? I can. No, I can't. Yeah, I can't. I can't use the iterator. That's a shame. Yeah, I don't like Godot. Now that I know how it works. That's that iterator. Now that I know how iterators work, I'm like, I want them. So it's dot. I mean, what if I do this? It's supposed to be a pointer, right? So I can get the begin. I guess I can just do... Yeah, let's actually just do that. So we have it minus begin, and that's basically the index. Oh, it doesn't... Okay, what if I do this? Oh my god. So I get the address. I do the same. Okay, and now I should have the because it returns this, so this is index. What a pain. What a pain. So I can remove this. And I'm just going to erase, like remove at. Or unordered, actually. That should still be good. Something like this. Well. Actually, I'm gonna do this. Yeah. So I remove, I have the same for object data. So that means this is going to copy everything that is afterwards. This is going to keep the order. Which is what I want if at some point I want to instantiate stuff. Maybe. Wow. I'm gonna have to modify this anyways at some point. So we remove, okay. We remove. Create object buffer. So, I mean, this should be alright for now. So we have the inject commands. So we draw, right? We draw. Wow. We update everything every time. Do we? Should we? Not necessarily. Is dirty, maybe? That's I don't care for now. Yeah. Wow. Yeah, that's fine. That's fine, that's fine. Okay. We update. Oh, there's just add entity. Where instance count 1. Yeah, this is fine. And first instance. I'm not sure about this one. Well, when I remove, that means I have to update everything. Yeah, I guess that's something to change there when I copy. I'm gonna do that here. So we have the inject buffer, and before that, I'm going to loop over the commands. And I'm going to do first instance. It's going to be, let me just change this. Okay, we have I, let's say. We have 32i equals 0. 2 I is less than this dot size, I plus plus. And we want the last one. So the first one is always going to be 0. So this dot first instance 0. Or like I guess I can have I mean because if I do that in a compute shader, then the goal is to dispatch, not do that on a single thread. But there's a counter. There's like an atomic counter. That's not gonna be the case for the array though, is it? I'm not sure. Let's not think too much about things for now. So we have I minus 1 dot first instance plus, well, this is gonna be last command. Yeah, this seems kind of bad. First instance plus this dot instance count. This is not const. We update. And this should be good. This should be good, even if we remove. Okay. Okay. So we update. Buffer update. Wait. This is indirect command. And yeah, that's mainly it. I can, you know, have a dirty flag to prevent updating like every frame, but that's fine. Well, that's not really fine, but right, that's still fine. It's not. Okay. So then the goal is to actually access this from the shader, right? Yeah, I guess that's what I want to worry about right now. So that means we need a descriptor set. Creates descriptor set. I'm gonna move it here because it's not a buffer. G2 descriptor set. And inside the descriptor set, we are going to describe. Woo! Crazy, I know. Every time we resize, not really, right? So I guess here. Well, okay, that's fine. Okay, so we have this. Let me go to the pickup render pipeline. Because we already have a descriptor set. Maybe not here, actually. Descriptor, wait. Huh? I don't have a descriptor set. What is that? Pickup render. Oh, uniform set. Right. Yeah, well. Let me check. Uniform set. Yeah, uniform set. My bad. I got confused. There's like something else called the descriptor set, that's why. And I mean, that's basically it, right? Like a uniform set is a descriptor set, right? If I'm not wrong. So we have this. We have a copy and paste, probably. Yeah, let's just copy out of this. Boom. If this is null. I mean, this is gonna be null. Like this. So we need the shader. Oh, so it has to be created after the shader though. Boom. Wait. Like, oh, it's here. Okay, so after the shader. Okay. I can remove this. I can remove... I mean, this is a texture though. But I mean, I guess it's supposed to be the same. I mean, I have the buffer already, right? So uniforms. I push back my storage buffer, which is object buffer. I create ID. Wait, what? Oh, the uniform. Right. Yeah, I have to describe it. If this is null, then I do a bunch of things. Yeah, I can remove that. Then I have the texture create. That's the buffer. I already have it. But then we have the uniform. So this is the uniform. Wait, let me just check. Oh, the uniform. There. So, object buffer uniform. Uniform type, no. Storage. I need a type, right? Storage buffer, I guess. But supports storage for compute mostly. Because I guess there's... I mean, storage should be uniform buffer. Regular uniform buffer. Wait, what's the difference? But supports storage. So you can output to it. That's what it means, right? So I guess it's just a uniform. And dynamic means it can be updated. Can it? I mean, I guess it should be this, I suppose. Binding. I guess binding 0 is fine because we don't have any uniform for now. And we want to append the OID of the object buffer. Then we want to push back this uniform. And we create the uniform set. Okay, sounds good to me, looks good to me, pretty simple. I can remove this. Okay, this is good. I mean, technically, I don't need this... Where is it? This anymore, right? I can just bind it now. Uniform set 0. Yeah. Yeah, I mean, good. Yeah, and I mean, technically it should be good. Technically it should be good. I'm also changing the first instance. So if I go to my shader and add, not this one actually, let's go to Visual Studio Code. If I go here and go to opaque, I have nothing in here. Okay, I'm gonna have my read-only buffer cube data. I guess something like this, right? So object data is this, right? And I'm pushing this. So just in case I want something like padding 1, padding 2, padding 3, because I want to pad it to 16 bytes. So now it means we have, wait, you int, wait, let me just GPT this. GLSL, well, uniform storage buffer, I guess, of struct. It's just about the syntax. So you have the struct and, well, okay, you just have it here. More compact. Wait, I don't know what the difference is though. I'm kind of interested in that. Structs containing arrays. What? Oh! Yeah, it's an array containing a struct. It's not a struct containing an array. Oh, okay, that's kind of hard to understand, but that's fine. Structs with nested structs. Yeah, I mean, you can do that. Common indirect rendering layout, and one thing to watch out for. Mat 4. Yeah. You need to transpose. I mean, that's fine. So SSBOs versus storage buffer, I guess, versus std this versus, I'm not really sure about the like really actually what it is. So SSBO, shader storage buffer object. A GPU buffer you expose to shaders. Okay. Storage buffer is the same. Okay. Okay. I have to remember this, that this is the same. But okay. So this, a memory layout rule for structs inside storage buffers. And this one is older. Mostly used for uniform buffers. Okay. Uniform buffer. Small, read-only, shared, 2 kilobytes. How do I arrange variables in memory so the CPU and GPU agree? Oh! it aligns a lot. Okay, well, basically that's what I'm doing. Wait, so... Wait a second. More compact. Oh! I got it. So it compacts different types. Oh, yeah, okay, I get it, I get it. Okay, that's fine. I get it. I get it. Okay, I get it. Yeah, that's... The previous one sucked. So let's say we have all of this. This is good. Then we have... Well, let me actually just check. Well, it's supposed to be a struct, right? Well, yeah. Let me just find it back. So on the GPU, on GLSL. Wait, how does it look like? Yeah, so you have the struct. There. It's like object data. You have mat4. That's like the model. You have the ID. And you have some padding. I guess we don't really need the padding. But, you know, it's just to explicit it. Well, we don't need it on GLSL, but yeah. So we have this, we have this, we have objects data. And this is cube data. Like objects data. The set, the descriptor set is, let me zoom in for you. Descriptor set is 0, binding is 0. Is the first uniform. Data, well, the layout is correct. So that should be fine. Read only. Yeah, I guess it's read only. Then I access it. Okay, well, I mean, well, how do you access it again? Objects. Yeah, so you directly use this, right? Like, I had like cube data or something, right? And I was doing. I don't even know where it is. Texture IDs. Okay, that's it. Okay. So objects data. We're gonna get this before. There. We are going to use, well, Godot GLSL instance ID is like Vulkan. I think it's Vulkan. It's like the variable from Vulkan because the names differ, right? You do not get raw Vulkan GL index. Wait. No, that's not what I want though. It's like my custom thing. So, okay, it's this. Yeah, it's this one. GL instance index plus GL base instance. Yep. GL base instance plus GL instance index. Normally. So we have this, we have the data right there. And from that we can get the MVP. So wait, we have MVP, right? Okay, so technically MVP, the M should be before, but I remember that it was different, that the order was different. So I think it's like this. And I think that's good. I think that's good. I think that's it. Technically it should be good. Is it gonna be... It's not. There's a problem. What is it? Shadow stage compiles gel-based instance. So Vulkan, gel-based instance. Oh, that's fine. It's just this, and probably this too, right? Yeah, okay. Right, like if I reimport. Wait. Never mind, that's still a problem. Wait. So we have this. So in OpenGL, it's GL instance ID, and now it's instance index. But why is it not working then? I mean, what about base instance? When to use base instance? To calculate the data index in Vulkan. Hello, Sammy. Hello. Welcome. Yeah, it's not finding base instance. missing. Undeclared identifier. Explicit. Oh, it requires. No! No! Shadow draw parameters. I mean, it's a question of. I mean, I actually don't know. Can you still compile it? Shadow draw parameters. But yeah, basically the goal, Sammy, is to render things. We are rendering things. And this seems to be 0. Oh no. Wait, true is 0, right? Like what is VK true? It's 1. Oh, so it doesn't support... Do I have to modify the engine for that? That sucks. Let's try something for now. So we have, well, base instance. Let's move it there. So we have this. Okay, now it's working. So base instance is working. Instance index is working, I mean. But this is not working, right? Yeah, it's not. Godot base instance not working. Well, GL. Maintenant. I mean, if you want me to show you the game, I definitely can. Well, I mean, I guess it's... Well, I'm modifying the shadow right now, so it's a bit difficult, but... Yeah, just tell me if you want me to. In the chat. If not, I'm just gonna continue. But I might have to restart the engine. Drivers. So this is in drivers Vulkan. I probably don't want to modify that, do I? Yeah, I probably don't want to modify that. So I guess what really matters is this. How to enable that. Vulkan HPP use reflects. Okay. Set shadow draw parameters. So where am I setting this? Well, where is Godot setting this? Nowhere. Huh, interesting. Godot enable shadow draw parameters. You need to use instance uniform. What? That's not what I... That's not what I want. I mean, I could just put a 1 somewhere and that's it. But I just don't like that. I just don't like that. I'm gonna have to modify Godot, which is like at this rate. You know what? Now that I think about it. Boom. Let's search for this directly. Maybe not. Maybe base instance. Can I access like the shaders? Like GLSL? Where are the shaders in Godot? GLSL... Well, Godot... Where are the shaders? Not this. In the engine. So, servers rendering, servers visual. Let me keep this one. Servers. Rendering. Wait. Or server visuals. So we have all of this. We have the ink, I guess. Okay. It's just headers. Wait. Wow. Can I go like there? And because it might not be added to the Visual Studio solution. So, okay. Or it is in servers visuals. Yeah, there's no visual here. Display. No. DDS. The DDS files are there. Fog, no. Can I actually look at this? Define. Oh! It's creating this directly in... Oh no. Shadow compiler is... Oh no. Okay. Okay, so technically it should still be here, right? Like if I have instance index, like GL instance index, it's already there, right? But now if I have GL base instance, for example, it's... Wait, it's there! I found it! But how is it possible? GL, well, strong, okay. Sphere 5. Oh, it's not in Godot. It's not in Godot. Entire solution. Godot third party. Let me just do GL base index. Boom. And as well, then you go to Chronos. Not index. Well, I guess we can... No, we can't. Is that like a search bar? Like GL instance index, maybe? Oh! Oh, wait! Instance index is already the right one. It's already good. Oh! So I don't even need... Wait, is it? Wait, I have to check this. The value is 0. Do I have... I can't... So stupid. What if I put index? Am I going to find... It doesn't exist. It's not even in the documentation. That sucks. So where can I find that? Built-in variables. Oh wait, that was it. Wait. Is that the official registry Chronos? Okay. So this one. Instance index. Only present when targeting Vulkan. Okay, this is good. And what is that? Vertex language input variable. Vertex, okay. That holds the instance number of the current primitive in an instance jocal relative to a base. Oh, so it's relative though. It's only present when targeting Vulkan. If the current primitive does not come from an instance jocal, this value is 0. Draw ID. So how can I use that? Like, is there GL base instance? Wait, there is a base instance. That holds the integer value passed to the base instance parameter of the command that resulted in the current shader invocation. Relative to a base, okay. See shader inputs. Yeah, can I just use that? Wait, what? Shader inputs. What is that? Shader inputs. Please. Fragments. Geometry, I guess. Geometry. Or not? Built-in variables. In section 11.139. Wait. Oh, maybe there. OpenGL, Spear 5 specification, Vulkan specification. OpenGL, well, it's OpenGL specification actually. Okay, OpenGL specification 11139. I have Vulkan and I have OpenGL. Pages. I don't even know where it is. Specification. HTML. Registry. Oh, wait. This one might be good. (11.139). It's just really big, right? Yeah. So 11.139. Google. Host memory. Wait, that's not good. Yeah, it's OpenGL that I need. So OpenGL. Is that... That's not good. A specification. I'm just gonna check this again. core profile, probably. This. I guess, wait, no, wait. I have this and this. My god. Oh, that's pretty nice. That's a nice diagram. So, let's find it, okay? Base instance, here we go. So, shader inputs. Besides having access to vertex attributes and uniform variables, vertex shaders can access the read-only built-in variables. GL base instance, GL instance ID. Okay. Base instance holds the integer value passed to the base instance parameter. And then holds this draw ID. What is that? Integer draw, number of the current draw being processed by the shader invocation. What? Oh, I mean, technically, maybe it's fine if I use this one? Wait, you have base instance, you have instance ID, holds the integer instance number of the current primitive in an instance draw call. So I mean, base instance should be there, right? I mean, base instance should be here. And if I look at the Vulkan specification, it should be a bit different. I mean, it's like really big. It's like really, really big. So I'm gonna search for this, maybe. And I'm finding it. Kind of, not really. Can I go down? Seems like there's something somewhere. What about instance index? Well, wait, okay. No. GL instance ID is replaced with this, which should be used for Vulkan in this extension. Resolved. Wait, resolved? It's like questions? Oh, it's an extension. There is no base instance relevant for these shaders. Wait, does it? What do you mean? It doesn't. ID is like identifier, not necessarily index. Right? But yeah, I guess there's a problem. Let's go to render path, no shadows. What about something variable? Variable. Descriptor set. Shadow interfaces, built-in variables. Okay. So GL. Yeah, I don't know. I have no idea. Well. Vulkan GL base index. It's not index, it's instance. Doesn't exist. Well. What is it? Undeclared identifier. And let me just let me just open a few things just in case. GL instance ID. There's a problem. So It changes some stuff. In particular, this extension removes GL instance ID and creates its own variable instance index. Okay. GL instance ID is the instance starting from the first instance in the instance drawing command. However, when base instance rendering was added, right, so that's what I have. The ability to render an arbitrary range of instances. Right. GL instance ID was not updated to match. So if you start from a base instance of 2 with 5 instances. Wait, what? Oh. What needle in a haystack are we trying to find? That's a good question. The goal is to use GL base instance. Is to use this to access. Well, basically, you know how I'm trying to render entities, right? So I'm using indirect rendering for that. My eyes. Sorry, my apologies. Can I turn it to dark mode? Maybe not. But yeah, basically the goal is we have objects and we are using indirect rendering to render them. And the data of my objects is inside this buffer right there. That's basically just a list of matrices that I'm using to set the position of the object in the world, right? It's basically the position of the object in the world. Now, the problem is that well, to access this data with the right index, I need GL instance index, which is working for like basically instancing, but I also need GL base index. That is because of the indirect draw. Sorry, my apologies. Can I turn that to stack overflow? I mean, never mind. My apologies. So it creates its own variable. If you start from a base instance of 2 with 5 instances, the first GL instance ID will still be 0. So the only things the base instance affects are instance arrays. Okay. Wait, is it? No, it's not. Actually, well, in OpenGL. Vulkan wanted no part of OpenGL's nah. This required a new variable. So I removed the previous one. Which will be for those using the GL, KH or Vulkan GLSL extension. Also, your extension declarations should be scoped as well. I still apparently need, well, I mean, this is a bit different. So, base instance, does it need, an extension? I'm not talking about Vulkan. Wow. Yeah, it's supposed to be built in, right? To access this value inside your GLSL shader. Extension, no. We should use GL instance index. Wait, so that's directly... It directly has it by default. I don't know. I mean, I guess it's supposed to be good. You know what? Let's say it's fine. So let's say we have this. I guess I still have to restart. Yeah, let's restart. And I guess we want to add multiple entities. So add entity, mesh, and transform. I just want to transform. What did I, well, like mesh, and then we have the transform, right? Register meshes, remove entity. So this is going to be the index, or like the ID. And this is going to be the mesh. Okay. Okay, let's hope this is fine. I'm just gonna, just in case, because the specification stays, well, the specification says that it's relative, so I'm not sure. It's like confusing. So this, those GL base instance take into account, well, those GL instance ID take into account, what was it? First instance. No, it doesn't. No, GL instance ID. I'm talking about, well, index, right? So ID doesn't take that into account. But you have GL instance index that is both. Okay. Okay. Okay, we get it. We get it. Okay, so it should be good. Well. Cannot convert. From this to an int. Remove. Oh. Oh, right. Yeah, I mean, yeah. ID. Should be good. Please. Please, please. Do I have any other problem? No. Just this. Okay. Good. Please. Why is it not? It should be good. Please. End my suffering. But no, it should be good. I should be able to add multiple entities. And the question is, can I set the transform to something different? And can I reuse, can I instantiate? That's the question, I guess. I want to try instantiating to verify if this is correct or not. Well, actually, no, I mean, no, it doesn't have to do with instancing, because I just have to verify if the base index is included is instance index. So I just need multiple meshes with different transforms to test that. Docker is making me depressed. Oh, you're using Docker? Oh no. I can feel you. I tried using it like one time, and then I came back to my C++ and my... Well, technically I guess you can put C++ in Docker, but you know, who needs that? Okay. So we have all of this. Are you ready? I'm not. Let me verify. Yeah, okay, so I actually have no entity, right? What is it going to do? Okay, it's actually rendering correctly. It's just not rendering anything, I think. Well, seems like we have a few problems. Can't create buffer of size 0. I mean, I guess so. Buffer is not a valid buffer of any type. Huh? Oh no. I think it has to be because of my create object. I guess I need the usage. Nope. Nope, nope, nope. are the buffer creation bits as storage, I guess. Like Godot C++ creates storage buffer, well, SSBO. Well, I mean, I guess I can just verify in the engine. Look at what they do. Nothing. Creation bits, well, that's me. What am I doing here? I mean, it seems to be good. I'm not doing anything special. Oh, I need the uniform though. I have to specify what the uniform is, probably. Let me just remove this. Uniform type uniform buffer. Wait, so buffer update. Buffer argument. Is it when I'm updating? Buffer updates. Because I might be updating already when I'm creating the array. Oh, but yeah, I'm not sure about that. Let's maybe go to here. So we have all of this. We register things, meshes, and I want to add entity. That's gonna have, well, let's have mesh equal this. So we have the mesh, string name. What? Oh, yeah, this dot meshes. So we have the first mesh, and we want a transform. Ready? How can I create this? Can I just do this dot? No. Yeah, how can I like set the position and stuff? Godot transform 3D create. Basis and position. So we have transform 3D. Basis is going to be identity. Or like basis, I guess. Okay, I can have that. And we have the position. That's gonna be 0, 0, 0. And then we're gonna have another one. That's gonna be 3, maybe. With an offset of 3. And we can start this. Let's try this. So, I still have problems. Mismatch. Oh, there's a mismatch now. And yeah, I'm not sure about that. So binding 0, set 0. Storage buffer expected, but supplied uniform buffer. Okay. I guess that's the problem. So this is storage buffer, right? Like uniform type storage buffer, right? Yep. Uniform buffer dynamic. Should I... Let me just check this. Memory allocation flag used in to allocate that stays permanently mapped for frequent CPU to GPU data transfers. Do I need this to be dynamic? It's not a valid buffer of any type. I'm not sure about that. But in any case, this one should be good. And I'm just going to copy the error and restart. I need to remove those errors because they're like useless. They're like not needed. And let's look at this. Or maybe this. Ah! Passing an invalid or uninitialized resource to buffer update. Am I? Wait. Argument is not a valid buffer of any type. Is it because I create this? Wait. Vertex object buffer. Is it because of this? Can the span so if there is a size, but there is no size in my case, and we already have those usage bits set. Oh wait, this is good. Wait, it's working. Yes. I wasn't expecting that. Look at this. We have two cubes with a different transform. Yeah. With two different commands. So instance index is good. Okay, this is really good. This is really good. Oh, this is so good. Oh my god. Okay. So we're gonna be able to start having some fun really soon. So what you wanted works. OOTB. What is OOTB? With Godot. Out of the box. Well, it's not about Godot, it's about Vulkan. But yeah. Yeah, it works directly. But it's about Vulkan. It's basically because OpenGL and Vulkan have some... Well, in GLSL they use... Basically it's the same language, right? But sometimes they differ a little bit with like variables. And it's sometimes a bit hard to understand like what something does. Well, in this case it was difficult. But it seems to be fine. So this is great. This is really great. Yes. Yeah, you tell me OOTB, I think about OBB, like axis, well, OAABB actually. Well, that's like OBB, oriented bounding box, something like that. But it's good. Good. Yes. We won. Yeah, Steam Proton is a big force for Vulkan. Steam... Oh, Proton like Linux, right? To make games work on Linux? Yeah. Yeah, I mean, I do appreciate... I mean, well, it's not even about Proton, it's like, you know, multi-platform Vulkan is good. Well, it's like compatible with like anything, right? Like if you use DirectX, it's only for Windows. If you use, what is that shit called again? Sat Magnum. It's, I forgot. Proton Wine. Yeah, it's like an API for Windows calls. Got it. How is it called? Like the Mac thing, the Mac language. Wait, I forgot. Well, it's not a language, but the API. It's not. I mean, Vulkan is. No. I forgot. Metal. It's metal. Yeah, I was thinking about something like a Vulkan, right? But Vulkan was, it's like already here. But it's this one, right? It's compatible. It's not Mac. But yeah, Metal is Mac's rendering API that no one uses. Well, maybe some people uses it, but yeah. I mean, this is so good. So I have different objects. I guess the goal now would be to not do all of that. So how can I update the transform of my entities? I mean, just by updating the buffer, I guess. So do I need to send it again every frame? I mean, I guess I have to update it, actually. I can also update it partially. But storage buffer create. Well, buffer update. I just wanna check something about this. Data skip check. Can you update? I mean, I guess it's a sub update, something like that, or the sub update. Well, Godot buffer updates sub part, and it is buffer update. Well, I guess it has to be the same buffer anyways, then. Maintain 16-byte alignment. Okay. Synchronization safeguards. Well, okay. Yeah. Alternative for meshes. Nope. So I just want to ask something to GPT about optimization. So updating buffer. Is it better to have a lot of small updates to some parts of the buffer, or update the whole buffer at once? Fewer larger contiguous updates. Yeah, that's what I was thinking. Don't upload unchanged data. To batch dirty regions. For GPU-driven rendering, rewrite the whole buffer every frame. That's what I'm doing right now. Persistent. Yeah, that's what I was thinking about that. I was thinking about having one buffer for, well, one buffer that's going to be updated every frame, and one buffer for like small updates. Good for stable objects. When you update, well, small updates, so you do this. Ring buffers per frame data. Avoid GPU waiting for data you're overriding. What? Okay. Visible chunks, changes every frame, instance transforms. Oh, okay. So, yeah. Yeah, so technically I might split it into dynamic, a dynamic buffer and like one that stays the same. But yeah, that's it. So it's working. Ah, that's so good. That's so good. I love it, man. Can I go? Yeah. Ah. I just wanna check my bug again. Where is it? It's around here, probably. Wow. Doesn't seem to be a bug, actually. What about here? When I go from here to here, there's no... Wait, there. I mean, there's no problem here. What if I destroy... Wait. I mean, it seems to be fine. Collisions seem alright. For some reason. Oh, no, it's not. Oh, it is. Never mind. Well, okay, never mind. It's good. Okay, so this is good. No crash. Perfect. This is good. This is really good. Okay. Great. Great. So I can add meshes with their transforms. And now I want something like textures. Or... I guess... Well... Yeah, so that should be multiple meshes. Yeah, so... It's like texture index. And then we have the UVs. And then we can bind. And that's just pretty good. That should be pretty good. Texture array, I suppose. I feel like I'm just putting everything on the GPU, but I mean that's kind of the goal, right? Texture. I was thinking about something, but if we want to optimize the rendering and, you know, like clean some stuff, then we can always, like, once the player goes to bed, for example, we can always optimize it at that time. So you know, the player doesn't really realize that this is optimizing, because it's like a black screen, right? When you sleep, I guess. I guess we can cheat like that. So freezes wouldn't really matter, right? Anyways. Where's some meshes? I mean, yeah, everything here is good. I can update everything too because I have the ID, right? It's like returning, add entity is returning an ID. It's not. It is going to. Well, add, wait. Here. Add entity, I return this, bah. It's supposed to be our ID, but that's fine, again. Wait a second. Wait a second. Return. I guess... Well... Oh, I guess it's something I set ahead of time. Okay. It's something I create ahead of time. Or that I can create here. Well. Next ID. Yeah, I can just have something like next ID equals 0, like maybe 1. Then we have this object data. I mean, maybe. Well, basically, and I want to, like, back. I get this, and I set the ID to the next ID, and then I do ID++, next ID++. And that way we always have like a unique ID. And then we return the ID. I could return this, I think. But just in case, object ID equal this. So I set the object ID and I return it. You know, just to be safe, let's say. To make things easier to read, maybe. Okay. So now it returns a key, basically. It returns a key to update the mesh if necessary, or like the entity, right? The transform, all of that. Good, good, good. Perfect. Really good. What should I do now? Because technically I have the transform. I can update the transform. Yeah, I have the texture. I'm just gonna push. I think I have to push. Looks like game. So we are gonna have this. We are gonna have this. And this is gonna be 32.1 opaque entity renderer. Now drawing with transforms. Really good. And I guess we're gonna have the same here. It's just going to be a single push, right? But it's good enough. Boom. Boom. Good. Perfect. So what now? We need the texture, and we need the, well, we need to update the transform. I mean, textures are not really a must-have, let's say, right? Maybe updating the transforms takes priority, because that's why I can have the game. I can have the game. I can retrieve objects, I was gonna say. Like retrieve my cues. Yeah, basically I can have my items. It doesn't matter what it looks like. So, well. Yeah, let's just update this for now. The texture is gonna... I have to update the texture anyways. For like the other blocks. Because they're not good. Well, they're not good. I only have one texture for all faces, which shouldn't be the case. Is what I meant. I was wondering about how to do that, but anyways. So, if I have the face index, actually I can probably switch. Anyways. So let's update. I mean entity, it's actually an entity. Update entity transform, maybe. So we have the ID. I mean at this point it's a OID. At this point it's a OID. It's a OID. It's well. Right. If I want to send it to the GPU, it's when it. But you know, that's fine. ID. OID. So let me just try OID from uint64. So I guess it's gonna be uint. This is a uint2. And then int32. Wait. Yeah, it should return OID now. Yeah, it's just not up to date. Remove entity, everything is OID. The only problem is this. Get ID. And we compare. We compare, and this is it. I still don't get that. I mean, it should be fine once I compile again. Okay. So then we have the update. Do we? Like, renderer.this. ID. What time is it? 8 AM. I feel like my day is gonna be hard if I don't sleep a bit more. But what should I do, chat? Should I sleep? Or is that for the week? Okay, we have date. So technically we can find this back. The same way. Right? Which isn't very optimal, let's say, but for now, we can basically have like a hash map or something like that if we want to in the future. Well, maybe, I'm not sure about that, but okay, we have this. We have this. We have the iterator with the model. And we want to update, right? So we have the transform. There. Boom. And this equals model equals transform. And that should be good. That should be good. So now I should be able to, for example, make the cube rotate. So let's just restart and let's try that. Actually, we need the, oh no. Ah! Quick. Updates. Boom. With the transform. Here we go. Here we go, here we go. There's not much. Yeah, so we do have some problems. Function does not take one argument. Well, wait, what did I mean, yeah, we have this. I guess I want to run this here. Well, I want to add this here. And I guess that's like the only problem I really have. Is it? I think it is. I can do that if I want. Okay. Let me fix this. View int. I guess it's the same. And it should be good. Right. This one is about the generation. Generation. Cube chunk generator. What about chunk loader, maybe? I don't remember. There's like a thread somewhere. Yeah, indeed, there is. Chunk loader, I suppose. No. I forgot. You know what, let's just do thread, wait to finish. And it should be not in core, not in drivers, not in editor, but in modules. Modules, chunk loader. Wait, not anymore. If it started, right? And, oh, collision loader. So, if this started, then I wait. Okay, that's like a quick fix, but you know, always nice. So we have this, we have two cubes. And technically we can go... Where should we go? Donut. We have all of this. And let's have, for example, cube 2. Test cube 2, like OID. It has an OID. And we assign it here to the entity we just create. And then the goal is in update, in process. We have kind of the same, but with update entity transform. We have test cube 2. And we need the transform, which is going to be something like this. Cannot get return value of call this because it returns, yep, I know. Okay. So we have this. We have, well, we have this. What about the basis though? What if I want to make it rotate? Godot transform 3D rotate. Depending on the time, for example. Rotated. So T2 dot rotated. Axis angle. Perfect. So the axis is gonna be vector 3 dot up, for example, and the angle is going to be time dot time. Like get time, get ticks microsecond. Is that in radians? Wait, yeah, in radians. So let's divide it by 10. Yeah. Integral division. Yeah, I know. Well, I can do that. Well, yeah. Something like that. Anyways, let's try this. Okay. So we have one cube and look at this. What is this? What am I doing, chat? Why is it at 2 places at the same time? Why is it at 2 places at the same time? Oh, because it's too fast. It's so fast that it's looping so much. Yeah, because microseconds is like, but is that micro or mini? I think it's milliseconds. Yeah, milliseconds. So I divide by this, and then, well, then it should be better. Yeah, here we go. Perfect. It's moving. It's moving. That's so good. That's so good. I like this so much. I'm basically re-implementing the engine. I'm basically remaking the engine. But now I'm going to be able to distort things with the donut, I guess. Wow! Does that really matter? No, it doesn't. But, you know. Well, right? I think I'm overcomplexifying things, but I like having control over my render pipeline. Yeah, this is really good. Look at this, look at this. The only problem is that it's not rotating relative to itself. It's not like relative to itself. Because I move it and then I rotate it. Well, I'm not sure about that. But I mean, it's a transform, right? So it should be good. It just depends on like the order of like the transformations, I guess. Does it? I mean, I'm actually not sure. Because it's like a bit weird. I assumed that it was fine. What if I do T2 that translated? And this is 300 T2. And now it should be rotating, but not around the origin. Okay, perfect. Perfect. Perfect, this just works really well. It's just perfect. So I have my item. I just have to make it really small. I mean, I can make it really small. I just have to scale this. Do I have to scale first, actually? I think I have to... Wait. So it's T or S, right? Translate, rotate, scale. So yeah, the scale is first. You're adding transforms for item drops? Yeah, I am. The scale is going to be like this. I'm just testing right now, but oh, vector 3. It's not really clean, right? I'm just adding my transforms, but you know, it's just to test, and it seems to be really good. It's just really good. I can basically call... Well, I can basically like add my meshes now and add my drops. I just need like a collision or something to retrieve them. But, you know, that's it. I guess I want a collision because I don't want them to go through blocks, right? Yeah, I'm just thinking it might become a bottleneck at some point. There were ads, I didn't hear anything. Oh no. So yeah, basically... Wait. I mean, you're just using Godot transform, boring. No, I'm not. I'm not using Godot transforms. That's the thing. I have my custom render pipeline that indirectly draws a lot of meshes potentially for entities. And well, basically now, as you can see, I can set the transform for my meshes, for my objects. But those transforms are not the transforms from Godot. They're like my own. They're like my own transforms. So I'm also bypassing all the Godot stuff, Godot boilerplate on that point, I suppose. And okay, and yeah, your super duper fast transforms. I mean, it's not really about the transforms, it's more about the indirect draws. Well, yeah, it's about the indirect draws. So, yeah, I mean, yeah, yeah, that's it. Because I have every object inside the same vertex buffer, and I can instantiate those draw calls too. Yeah, I know, I'm talking like the old magic language, let's say. But, what's indirect draws? It's what I've been doing for 3 days. So basically, to explain it. And normally, well, when you draw normally and directly, you basically have a loop. Where is it? You basically have this loop that iterates over all of your objects that you want to render. And inside you have, for each object, you have, well, not this actually, but this one. For each object, you have draw list draw, right? And the result is that you end up with where is it? You render, well, you end up with all of this, right? All of those little draws, right? That end up taking some time. If you have like a lot of objects, it's taking some time. I'm gonna make a screenshot of that actually. Okay. Okay. So yeah, and basically indirect draws repeat. So this is direct draws, right? It's like pretty. It's taking a lot of. It's taking a lot of time, or like maybe an individual call, not a lot, right? It's like 2 microseconds. But if you have 200 chunks like me, it's like basically a lot, right? It's almost like one. Well, yeah, it can go to like some milliseconds. And with indirect draws, you have instead, well, in my case, what I do is I have everything inside the same vertex buffer. So I can just bind everything one time, every frame. Like, this is just bound one time. For, well, yeah, one time. And then I call this function with the draw indirect. And it's just, you know, just one time. It's just one time. That's it. I don't have to spend all my time trying to, specifying like what object I should render and that kind of stuff. So it's pretty good. Actually, if I go inside, there's no backface cutting. I'm probably going to add some backface cutting. How do you do that? Godot, add backface cutting to the pipeline, I guess. Call mode, custom shader. What about rendering device? Call mode flag inside the rasterization state of your pipeline. So it's the pipeline. Got it. Opaque entity renderer. I mean, I can get a lot of performance. Technically. Let me maybe just push things one more time. Like this. Pretty simple, but good enough. 42.2. And this is going to be... What is it going to be? Yeah. Opaque entity renderer. Objects, well, transforms can now be updated. Pretty simple. And I'm gonna have the same. Well, I'm just gonna push this. To have like an example. Yep. And this is this transform updated. Okay. So backface cutting. Well, I mean, that's not the priority, but I don't want to do things too difficult for now. So I'm just going to enable this for entities because I still want to debug my chunks actually. Well, I mean that's just going to be one value though to change. Where is it? Color blend. I mean, no. Depth stencil. Mastery. Oh, it's there. There's this. Cull mode. Hey! Hey. Polygon cull disabled. Front face. So it should be front, probably. I'm actually not sure. What's the default? Front. Well, that's for me. What if I do this? Okay. What about back? I guess back is... well... code mode for the global illumination. Okay, what about back? I don't know, I have no clue. I mean, I guess we just have to restart. Wait, oh, sorry, I didn't see your comment. I'm gonna read it. I'm just gonna restart first. So I can, read your comment in the meantime. So you draw all the same textures in one draw call or something? Not really. It's not about textures. It's about meshes. It's about meshes and objects. And it's not the same draw call, but yeah, it's optimizing the thing. You still have multiple draw calls for each command, from what I understand. But it's like, it stays on the GPU. I don't have to update it. Technically. Like, technically what? Technically, in one case, you update every frame your bindings, like what vertex buffer you're using and that kind of stuff. But in another case, like, all of this is already... Well, actually, it's not such. How to say it? Anyways, PvPing. Yeah, well, I guess in one case you update every frame, in another case you put on the GPU the data you need ahead of time, and then, like, every frame is just fine, it just accesses the data. So you don't have to update again. Kind of. It's like reducing the amount of changes you need to do, I guess. So, wait. Let's start. I wanted to check the culling. When I'm inside, it's not curled. Is it? It's not curled. Yeah, there's no... Where... I guess there's something there, for some reason. I don't know why I have this. Polygon callback. Front faces pointing towards the camera. Oh, that's probably why. I guess since it's red, I can't see it, but... Yeah, okay, I get it. So it's probably working. But because I see the faces that are not facing the player, I still see the cube as a whole. From any place. Well, do I? I don't know. But let's try with back. What is there inside? I wanna check what there is inside. Please, pretty please. Like here. I can't go inside. This is forwarding. I want to go to rendering device types. Well, types maybe? Server types. No. Let me go in! Ah! What if it's structs? Well, structs. What was it? This. Wait, oh, there's a problem. Oh, yeah. My game is already running. So I just want to check this. Good. I just cooked some delicious food. Oh, you can envy if you want. Oh, I will. I do want to eat like some pasta or something. You're making me hungry. Line width. Oh! So you have that. Depth bias, so depth bias is fine. You have the cutting, you have the wireframe. Oh, you can display the wireframe. Enable depth clamp. I'm not sure about that. Well, never mind. Then you have discard primitives. What do you mean? But I guess the backface cutting is the most important. So now we run. And we still have the cues, but when we go through this face, it's invisible because from the inside, the face is pointing towards the inside or curled. So now it's working pretty well. Optimization, baby. Woo! Good, good, good. Good, good, good. Perfect, perfect, perfect. Just perfect. Just really good. All of this just for my donut. But I mean, I'm learning things, so I like that. Okay, and now I want to spawn that with a collider. So... in that case, I mean... do I want like a node for like those items? Because I have to bind the collider, I have to connect the collider to the mesh, right? To like the object, to the visual. Yeah, visual is a nice word. So how to do that? How to do that? I have no idea. Instead of a node, it can be an object. It could be an object. But then that means I can't modify it in the editor. What is your opinion on plain colliders? I mean, what do you mean by that? I mean, they're just colliders, right? They're like pretty efficient, if I dare say so. I mean, flat. Yeah, I mean, they're pretty efficient, I guess. Not I mean, technically, they're convex. Like a bunch of triangles. Huh? Like two triangles, right? Because the plane is just two triangles. Not a bunch, right? 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 So how am I going to organize my entities? Are they going to be nodes? I mean, nodes would be the easiest thing to do. So I would have my node that contains my collider, my visual, and then it just does things. And I guess that's it. It feels like kind of... I mean, I don't need that. I just need like an index, something like that. And I need the transform, the donut transform. Yeah, I guess the donut transform is like one of the things I need to do. I can see that there's no anti-aliasing. Oh no. That's fine. That's not fine. Why is there no anti-aliasing? I thought it was supposed to... I mean, I guess I have to... I don't know. Maybe there is. Anyways, so a node, a resource, an object, maybe just an object. I should still be able to access it from GDScript. I mean, it's not as if I can click on this in the editor to inspect them, right? So I guess an object might be just fine. So that would be like a gameplay entity though. Collision, generation, inventory, maybe like gameplay. It's like already 8 AM. I hope I can go back to my normal rhythm soon. I feel like I won't be able to, but yeah. So let's say we have all of this. You know what? You know what? I'm gonna make my modules. I'm gonna... Well... Wait, what is that? Right. I just add both of those. Oh, whoa. Not those. This. And this. 42.3, and it's basically entity backface cutting enabled and collision loader. Only waiting for Fred if it started, I guess. And now we want to reorganize our code. We want to reorganize it into different modules. So I mean, I guess that might be for the next time. What time? Well, 8:30. I do want to... do a few things. So let me just... GPT. Godot, C++ module. Actually, do I have any example? Register types. I don't think... If there is register types, I probably think there's no submodule. So create submodules inside a folder. Well, inside a folder, kind of. So yeah, I can have this kind of thing. Oh, it does not treat them as independent modules. It knows everything. Register type, adding sources recursively. if I want this, then I can make another folder and I have a custom, well, a new SC sub for each different module. Drawbacks. Separate initialization functions. Boilerplate, that's fine. That's fine. Harder dependency management, that's fine. Classes must communicate through Godot APIs or shared headers. Yep. Nope. I want to split things. So it's SC sub and register types for every module. Okay. So what are we going to have? We need something clean. So collisions. I mean, I guess I'm not even using this anymore. Utils. Wait, utils is... I mean, I do want to reuse utils in a bunch of places. But if it's just a header, I guess it's fine. Referential is useful too. I mean, I guess it should be like in core, maybe. Maybe in core. What if I want a module to be a dependence of another module? One of my modules. Well, let's say that. Oh, it doesn't have that. You usually handle it in one of those ways. Put them in the same module. Nope. Make two real modules and control build order. Oh, okay, so it's about the build order. I'd include path. Create a shared stat. I don't want that. Use Godot's module dependency mechanism. Oh, it does. In config. Right. Huh? Can build. Then you can check whether another module exists. Yeah, it doesn't link dependencies and stuff. I do want different modules. I want to reuse them. I just need to understand how it truly works. SC sub. So I append. And I also have the config. Can build configure. What if I go to the parent modules? SC sub, perfect. And we have module builders. So I can basically just, you know, look at this and take some inspiration from this. I don't understand. Register type. I mean, okay. What about this? Godot module. Okay. Oh, that's like define. Okay, that's a define. Name path. And there's a loop though. For each module, I do something as conscript. So I run this. Okay. And for tests, I do things. Environment module sources. If it's valid. Add library. Oh, got it. So yeah, it's this function to include like a child folder. I'm gonna have to move so many things. But that's fine. Voxel collisions. I mean, technically, I don't even have to move everything. I can just, for example, put something there. Oh, well. I need the core. I guess the first thing I need is the core. I need the core here to have its own register types, SC sub, and config. There. I guess this is fine. This is not gonna be fine. The register types, for sure. And I mean, technically this one should be good. Technically this one shouldn't change. Yeah. Maybe I can remove the debug, but that's it. And two register types. Voxel. Right, I mean, I have to define my module. Do I have... Okay, I don't. How can I define my own module? Okay. I want to split into different submodules. Show me the SC sub, something like that. Register types, extra, etc. So we have all of this. Dependency. Voxel core module. Wait, is that the Python? Yeah, I don't have to define the class. So can build true. So it's voxel core, I guess. SC sub. Import env. Register types. Yeah, I mean, this is basically good. Oh, there is this, I guess. Well, that's the header. That's a header. Well. Okay. Initialize voxel. Yeah, I guess I need something different for that. Voxel core. Yeah, I mean, maybe a voxel core. Something like this. I'm fine with that. Voxel rendering module. Yeah, I mean, I don't really care about all of this for now. The important part, module initialization order. However, your functions need to be exposed to Godot. Yeah. Huh? Wow. Okay. Naming convention. Yeah, I mean, this is fine. Dependency initialization. Sharing private C++ code. Huh? Then happened. Huh? Huh? What? Huh? Oh. Well, I mean, that's fine. Okay, I mean, technically it's saying that it's fine, but it's not gonna be fine. Other C sub gonna get detected automatically. If not, how? They are. Yeah, they're like in modules. Well, they should be in modules. But do they scan inside too? Can I have a module inside a module? That seems really bad. Maybe I can just split for now. As long as it has config.py, it's good. Maybe I can just make multiple modules. Well, but I want it to be in the same Git folder actually, so no. Probably not. Well, for now. Needs to know your initialization functions. Yeah. I mean, I don't really care. So, can I have a module in a module? Sure. First level folders. Yeah. Submodules. Huh? SC sub. So wait, there is config.py, but wait, that seems good to me. But only voxel. Well, okay, there's only one module. I want multiple libraries and yeah, dependent modules side by side. Side by side. Fake nested modules. Yeah, I do want this. I mean, I'm probably just gonna have this, right? But they're not modules. They're fake. Are they? I mean, that makes sense because library creation is on top. Oh, I can have like symlinks. Like, what about if I create shortcuts? Or what if I want my modules to be outside of the engine? Creating shortcut symlinks. Yep. I can have that. Okay. Yep. And outside, symlink. Well, okay. And add your own module path. External library instead of a module. I don't really care. Recommended architecture for Yeah, I mean, I probably won't. I mean, shortcuts would be pretty great, wouldn't it? I think folders are the way to go. Symlinks. I mean, comments can be pretty good too. because that way I wouldn't have to modify the engine really. Module path. I mean, this seems pretty good too. I mean, technically I can have my modules at the same place as the game too. Wait, that's pretty good. Oh, thanks for the follow! Pass Rice. Welcome, welcome. You're making me want to stay, but 9 a.m. Hmm. Thanks for the stream as well. Oh. Do you want to see what I have? Have you been watching for a while? Or did you just join? Because basically, this is a game, right? It's like Minecraft. No, just joined. Oh, perfect. Then yeah, this is basically the game, right? And almost everything is custom. Are you a programmer? Do you make games, or are you just like interested? It's to know how technical I can be. Yeah, programmer, perfect. So yeah, basically, it's a donut. And even though I'm on Godot, I remade the rendering to optimize it. And to have the donut also. And I also remade the collisions, like those collisions that you're seeing right now. They're actually made by me. It's not like the Godot physics system or anything. And it works for like any convex shape. So that's pretty nice. It's working pretty well. We can go down. And you know, things just work, right? Generally. Own rendering engine, kind of then? Or rather adjustments. Well, basically, I'm not modifying the engine, right? Like Godot already has its own render pipeline. And I'm using it, for example, for the UI, right? Because I don't have to modify the UI. The UI is pretty nice. But for the meshes, right? Like every mesh, basically. Well, except like this thing that I have to remove, I guess. But like the blocks and stuff, they're basically inside. It's basically something made in a compositor effect. And I basically create my own vertex buffers, index buffers, pipeline, like render pipeline, all of that. And I'm not using the meshes that, you know, Godot has. I have my own meshes with their own data. That makes me, you know, that makes it possible to like optimize a few things, whether it's like memory or speed, I guess, kind of, that kind of stuff. Same for collisions. Like collisions using Godot's collision system was pretty... Well, I basically have to spawn my collisions dynamically. Pretty fast, right? Because, like, when I move from chunk to chunk, etc. Well, I mean, I could keep the colliders registered. Well, no, actually. Well, basically, when I spawn a new chunk, I have to potentially register its collision, right? And it became like, it was pretty slow. Like it led to some freezes using Godot's collision system. So I made my own. And it's like more optimized because of other things on top of that. Because of things like specific to voxels. And yeah, that's basically it. And right now what I'm working on is this. So basically I have my voxel, I have my render pipeline optimized for voxels, right? For like displaying cubes and stuff. But then I have a new render pipeline now that I'm creating that makes me able to spawn entities that have meshes known ahead of time. And it's like very optimized because I'm using indirect rendering. And yeah, I just have to put some texture. I can change the transform, as you can see. And the goal is to, for example, spawn that when I break a block, like there, so I can get the drop. But the goal is to also be able to use this for my enemies and, you know, my other entities, right? I'm just gonna have to, well, basically, since I have my own custom render pipeline, I have to change a lot of things. Well, I have to re-implement a lot of things. Like, for example, I'm gonna have to re-implement skeletons. Well, skeleton meshes. Well, you know, like the skinning, basically, on the GPU. Animations. You say custom render pipeline a lot, I know. It's because it's like a very big word, and that sounds impressive, when it's actually not that impressive, maybe. It depends. Well, you had shadows, yeah, of course. It's like on the list, you know, like with ambient occlusion, because it's definitely lacking some shadows. But it's not the priority, right? The priority is to have a game. Because there's like a lot of people that just build engines on YouTube and stuff, and that are just continuing to build the engine, but that are never making a game. Very fancy, yeah. Sure. Well, you had raycasting lighting. Not raycasting, but ray marching. So yeah, basically, well, ray marching. Well, I want ray marching for like fog, for like volumetric fog. I'm not planning on any raycasting right now. By raycasting, what do you want with that? Do you want like reflection, for example? Do you want like the light to be sampled from like, is it like for the ambient light? Oh, raycasting lighting, never mind. I guess, well, in that case, let me think a bit. Well, not for a long time, right? I don't want to say yes, because the answer is I'm not gonna do that for a very long time. I want to add shadows, like I want to add ambient occlusion pretty fast, because I think it's a must-have to be able to differentiate the blocks, right? And shadows are pretty important too in general, but other than that, I need a game. I need a game first. Do you do Vulkan? I use, well, basically Godot is abstracting Vulkan with the rendering device. So I'm just using the rendering device, but basically I'm calling the functions, you know, that Vulkan has. Like, you know, I create my pipeline. I create the pipeline there, that kind of stuff. Ray tracing, I mean. Yeah, I mean that now. Okay, I didn't know that. Yeah, it's like pretty nice. Because, you know, the goal is you want an abstraction to be able to switch between Vulkan and DirectX. And Metal, I guess. Why is Vulkan better than OpenGL? Well, the goal is for multi-threading. It's been made for multi-threading on the, well, so, you know, you can multi-thread things on the CPU. You can multi-thread things on the GPU. That's what it does by default. But with Vulkan, you can multi-thread, how is it called? You have the swap chain and, well, commands, basically. Well, queues, you have queues to submit to the GPU asynchronously. That's the reason. And I guess another point is that Vulkan is... Well, OpenGL has a global state, but Vulkan doesn't. It has like objects, so I prefer Vulkan because of that. It's like less dirty. You know what your objects, well, where your objects are and the states they are in. Well, I mean, there's like a bunch of different reasons. Like, you have more control with Vulkan, right? You can like create your swap chain. You have like your... I was gonna say image views and stuff. Yeah, you have like descriptor sets. I don't remember if they have that in OpenGL, but yeah. Yeah, let's actually make a game. Wait, no, I was talking about my folders. That's gonna be a pain. State machine. I thought everybody loves state machines. It's not about a state machine. It's a global state I'm talking about. So core. Yeah, if I have something like modules, well, more like a symlink. I mean, it's a shortcut, right? Is a symlink the same as a shortcut? No, it's not. Work at the file system level. Or it's invisible. Okay, so how to create it? Windows create symlink to folder. mklink d yd a directory. Got it. Thanks for the insights, by the way. You're welcome. If you have any question, go ahead. I might stop the stream soon. I don't see much difference between states and state machines. I mean, a state machine has multiple states. That's a difference. Right. That's how smart I am. Too bad I do nothing. The world would be a better place if talented people like me were somewhat active. LNS-S on Linux. I'm on Windows, sadly. Anyways, how are you doing? Yeah, that's a good question. Bunch of states is state machine. Yeah, you can say that. Yeah, let's just do... So we have mk link d. can I just create, for example, voxel core, and this is the actual path. So the actual path is going to be voxel slash core. More something like voxel core. Invalid switch. Huh? What do you mean? Oh, is it this? Syntax of the command is incorrect. mklink d directory. I don't know what the difference is between a hard link and a symbolic link. That's like the first time I'm actually creating symlinks. So what do you mean incorrect? Do I have to specify like link and target? Doing fine, thanks. Hope you're having a good time as well, apart from regrets. Oh. mklink. Tell me everything. Examples. Oh, so it's like relative. Like this. Wait, oh, I had, okay, my bad. Yeah, okay, should be... There's no sudo on Windows, right? No! How do I open terminal admin? Windows R. Oh, never mind. Windows plus X. A. Click yes. What? Wait, pin Windows terminal to the taskbar. Oh, yeah, I mean just... Yeah, okay, you know what? Let's just do this. I'm gonna open the CMD again, but this time run as admin. Poo cd. It's not cd, is it? It's I forgot what it was. MV? No. Wait, what is... Users? Wow. Oh, so this is correct. Okay, so let's do this. Well. Like this. Well, oh, okay, it's because of this. Okay, good, good. So here we go. It's in admin. And now I can symlink my stuff. So, not this. mklink d. So the new folder is going to be voxel core. And then we're gonna have the path. So voxel slash core. Invalid switch. Right? Because Windows is just bad. And symbolic link created. Perfect. Perfect. Ah. Wait. Boom. I'm just gonna copy the commands so I can create new ones. And okay, we have the symlink. So what does that mean? Modules. Poof. We have VVV, voxel, please. Are you sure about that? I don't have it. Name. Date modified. I'm not sure about that. Voxel core. Yeah, it's not existing. Wait, so where was it created? Godot? Modules? Ah! Is it at my root? Oh, it is at my root. Okay, my bad. Okay, so I need the full path. Relative path. Yeah. I guess I just don't need the slash. Like if I do this. Okay, it's not in C. It's in... Here we go, voxel core. So we have the symlink. So we have the symlink, so it should be detected as its own module. And it should be good. It should just be good. Okay. I feel like that's going to be a lot of things to change. But like what happens if I if I go to Godot, it takes some time. But we're going to build readme scons this one. Template, nope. This one. Boom. Let's close the editor. Okay, it just generated. Wait. 2 environments with different actions were specified for the same target. And graph. Yeah, it's core, right? How can I solve that? I mean, technically, I could just move my folder outside of... Oh, I guess that's an idea. As long as I have the symlinks, I can just move my folder outside. Right. Like I can basically move this out, right? That just means I'm going to have to move things around. But not that much. You know what? We're gonna do that another time. Because this is gonna take a lot of time, I feel like. And I have to sleep. It's like 9 AM. I have work. Should be good enough. Godot. Do we have someone on Godot? UI is fake and cannot hurt me. Interesting. Wait. Yeah, you know what? Let's raid. Is game dev also your day job? Yeah. Engine programming. But it's not about this. It's not about this game, right? I have some. Yay. It is. It's like a really nice job. And I mean, I basically stream every day. Like the time is, you know, it depends kind of when. Like sometimes, right now it's like the morning, right? Usually I stream at night. But yeah, should have followed this path as well. Oh, what did you do? What did you end up becoming? Studied game engineering after all. Oh, but no, a Flutter dev. Oh, isn't that like some high level? Is that web? No, it's an app. I see, I see. It's for apps. Got it. Yeah, I'm really bad at high level things, like web development. Like, I should really learn how to... I guess I don't want to spend the time on it. There are just so many things to learn. Compiling to native assembly. Got it, got it. It's more like Java and C#. Okay, okay, I see. Okay. Yeah, I do know those. I've used those with like Unity, Minecraft plugins, mods, that kind of stuff. But yeah, it seems time is running out. So thanks a lot for watching. See you next time.